going to work backwards. So I'm looking at number 11 on page 203. We have the equation y equals negative 4/3 x plus 1. Okay? You need to graph the equation on a separate piece of grid paper, which is what we're doing. So first of all, when I'm given slope-intercept form, I know the slope, correct? What is my slope?
Negative 4/3.
So m equals negative 4/3. I know my y-intercept, correct? What is my y-intercept?
1.
1. A y-intercept, what is the x-coordinate always? 0, right? Because it's on your y-axis. So if you are on this y-axis right here, that means that x is 0. Okay? So x is 0, and then my y is the number that b is. Okay? I'm going to first graph my y-intercept, which is 0, 1. So I'm going to put a dot at 0, 1. And my slope tells me that I go up or down.
Down.
Down, how many? Rise over run, so I go down how many?
4.
4. It's rise over run. So I go, negative 4 means to go down 4, so I go down 4 from the dot I just graphed. 1, 2, 3, 4. And then how many do I go over? 1, 2, 3. Put a dot. From that point, how many do I go down? The slope's the same, it didn't change. So I go down how many?
4.
4. 1, 2, 3, 4. And then I go over how many?
Oh, that's
1, 2, 3. You need to have at least 3 dots when you're graphing a line.
Okay.
Now you can connect your line, and that is how you graph using slope-intercept form.
That's a pretty short one. Do negative 1. So it's negative dot 4.
Yep.
You write your line.
Now can we do the
Dot 4 and over 3.
count or now you can do
We already know the slope, so we don't need to. We're just graphing it.
The dot 4.
Okay?
Oh, wait.
Negative x plus 3 over 2. I'm given slope-intercept form, so I can figure out my slope. What is my slope?
Negative 1.
It's negative 1, because remember, you can put a 1 there, and it doesn't change it. So your slope is negative 1. Your y-intercept is what? 3 over 2, which is the same as
1 and 1/2.
1 and 1/2 or 1 and 5/10. Okay? So again, what's my x always in my... Good. And then my y is?
1.5.
Questions so far? Because that's where b is. Okay, so then I graph my y-intercept. So I go to 0, 1.5, so that's in between 1 and 2. Right there. And what's my slope?
Minus 1. Negative 1.
Negative 1. It's an integer, so I can put it over what?
1.
1. So that way I have a rise and a run. Okay? So any whole number or integer, just put it over 1 so that you remember your rise is the top number, your run is the bottom number. So I'm going to go down 1 and to the right 1. So I go down 1, so I'd be at 1/2. And then I'd go over 1, and so I'd be at 1 and then 1/2. Again, I go down 1, over 1. So I would be at 2 negative at 1/2. And I have 3 points. So I have a slope. Okay, I will tell you, and I don't want to confuse you when I say this, But do you think it would be true if I went up 1 from my original point? If I went up 1, which direction would I have to go to make it true? To the left, right? So if I went up 1 and then left 1, do I have a dot on that line?
Yeah.
Yeah. Okay, so I don't care if you put your negative up top, which means you go down, or if you write it as 1 over negative 1. That just means that you go up 1, and instead of going to the right, we're now going negative, so we go left. I don't care which way you use it, because it'll still be a point on that line. If I just confused you, don't listen to what I said, just use this one that we started with. Okay? Last one. Number 9. Y equals 1/3 x minus 5. One-third x minus 5. My slope, Will, is what?
1/3.
Yep. My y-intercept is what, Michaela? -5, good. Gavin, what is my x-coordinate always in a y-intercept? What's the x always in a y-intercept? What? That's my slope. 0. And then my y-intercept is -5, so 0, -5. I graph that point. So I'm at 0 and I go down 5. My slope, rise over run. How many do I rise, Layton? I go up 1, and then how many do I run?
3.
1, 2, 3. Put a point. How many do I rise?
1,
And then I go over?
3.
Is there another way that I could do it so that I could get a point to the left of my original?
Yeah.
What would I do? What?
Would you do?
No, because that would change my slope. Is 1 over 3 the same as -1 over -3?
Yeah.
Those are the same, right? So technically, if I started on my y-intercept, if I go down 1 and then left 3, that will also be a point on my line, correct? And there's your line. I'm just showing you that you can. Read it for me, Michaela. Number 8. Okay, so we have to graph the equation. Okay, am I given slope-intercept form?
Yes.
This is like the one I gave you yesterday.
No,
It's
no,
the
it's
one
backwards.
backwards.
Yeah, you just have to.
It's backwards. So
-65x
y equals -65x
plus 1,000.
Good. Just rewrite it so that it's in the form that we're used to. So now I need to graph my equation. What's my y-intercept?
Your y-intercept is 1,000.
So I graph that first. In a y-intercept, your x is always
0.
okay, so I graphed that. What's my slope?
Your slope is 65. -65.
What can I put that over?
1.
Good. So I go up or down?
Down.
How many?
65.
And over how many?
1. 935.
Okay, so we would be at 935, Achille says, so a little above 900, and we'd be at 1, so about here. Go down 65 from there. What would you be at?
870.
What? 870. Achilles using her calculator to take it and subtract it. So 870 would be just above half. Let's do one more. Our slope. 805, so just above 800, and remember you're always going over 1 as well. Okay, so then you can draw a relatively straight line. And just continue that line. You don't stop where the dot started. Your line continues on forever. Okay, so now I need to interpret the slope and the y-intercept. What does my y on my label for my graph should it be? What should the label on my y-axis be? Miles, yep. Represents the distance in miles. And this one should be hours. Okay, so to interpret the slope, I have negative 65 what? Miles, because that's my y, per 1, which is my x, so I label it hours. That's my slope, so I'm going to negative 65 miles per 1 hour. And then my y-intercept is what? What does that 1,000 represent? The distance which they started their trip.